Hello everyone, today we're going to be discussing the steps a team should take before they start building their robot. Here are some of the teams that you're going to take in mind before building. It's important that you plan things before you start building, and in general it's a good idea to fully plan out your motor distribution, subsystems, how those all fit together, and understand how everything will be working together in the end when you complete your robot. In general, you want to know the important aspects of each of the subsystems before you start building. This means knowing how long and wide your chassis will be, what wheels you'll be using, gear ratio, how many motors, etc. In a lift, you'll want to know how long the bars you're using are, how wide it'll be from tower to tower, what gear ratio it'll use, and just stuff like that. These are just a few examples of the many little details that you should know before you start building. Planning these out with your team beforehand will allow for a better envisioned final product for all the team members, and it'll minimize the need to rebuild and change different subsystems along the way. One of the most common problems in VEX is when students want to jump in and just begin building before they have fully planned out how all of this will fit together. So you'll have a team working on a lift, a team working on an intake, a team working on a chassis, and you don't want to jump into building this and then realize you've left absolutely no space for the lift you decided on. And you want to make sure that you know how you'll be attaching the different subsystems together as a whole. Remember that bracing, attachments, and other parts do take up space, and when there's less space to work with, your options are limited. So this team had taken that into consideration, and they have some mountings on the back where they can easily slide in this conveyor and shooter system. I believe this is a flywheel mechanism right here. And so it's easy for them to slide it in and out and mount it. Same thing for their intakes, right? You can see how they easily have that all compatible with their robot. As for CAD, some of the more advanced teams will use this CAD or computer-aided design in order to make their model robot before they build it. And this allows for a really good idea of the problems you might encounter in the future and the possible workarounds to allow for the smoothest time possible when you're building. So a lot of teams will go through and just do everything that they can, and then you can figure out what your spacing is going to be, what the distances are, and all of the specifics like that. So one of the worst mistakes a team can make is jump straight into building without planning whatsoever. Almost all of us have done this in our experience at some point and another, and we just began building robots. If you have not, then you're lucky, but when students do, there's a high probability that many issues will arise that'll hinder the build simply because it was not thought out. Though planning may take a lot of time, a team would waste more time if they had to go back and rebuild every few weeks due to more and more problems arising because they didn't think about the build. This leads to a situation we all know, finishing your robot a few days or the day of a competition and showing up with some non-consistent programming, autonomous, and little to no drive practice. So a team right here, obviously their robot is working and really functional and it's a good robot, but one of the things that they probably had a little bit of a struggle with is their mounting, because you can see they did plan out having an X chassis like this, but they're so limited on having these structural C channels on their chassis that they were limited to just having this one bar, and that's why it's kind of all so condensed down here. And that's just one of the things that teams would try to avoid when having more and more and more planning, but obviously it'll still work out in the end if you do find another way. And then again, the golden rule of X is to ask yourself why you're doing this. And you guys should all be able to explain why your robot is the way it's going to be before you even start building it. You should be able to give an answer, or at least be able to think of an answer to almost any question about the robot and how it's going to be built or why it's going to be built before it exists. So if we ask about what your gear ratio is going to be for your chassis, we're going to ask why you have these flaps right here. We're going to ask why you decided on an intake like this. And this is one of those robots, just for another example, to see how they did end up planning it really well. This is probably one of the most compact robots that I think I've seen and the most well-functioning. And it does obviously use a lot of parts, but you can see there's a lot of structure in here that allows for them to mount a lot of their subsystems close to each other and having enough clearance for them to combine all of these. And then when in doubt, if you do need more build space, a really easy solution to create more build space without interfering with your wheels or your chassis is just by attaching some C channels on here, or some standoffs onto your C channel and making an elevated platform. So you can see up here, this team added some more C channels up here for a gearbox, and then they just added another motor over to their chassis. And what that does is it gives them a little more build space, and it makes it a little bit easier to add more to their robot. Thank you for watching.